Welcome to an introduction to oxidation reduction reactions. In this video, we will be looking at just half reactions, what they are and how they work. So firstly, we're going to look at electrochemical reactions. And basically what an electrochemical reaction is the transfer of electrons resulting in a change in the oxidation state of an element. So we're basically just looking at how elements or compounds are changing their oxidation states based on a reaction that's taking place. So firstly, we get oxidation, which is the loss of electrons. And we also get reduction, which is the gain of electrons. So one compound is going to gain electrons and one is going to lose electrons in an electrochemical reaction. And an easy way to remember which one is which is there's the little rhyme that goes oil rig, where oil stands for oxidation is loss, and rig stands for reduction is gain. Another way to remember it is Leo Gur, like Leo the lion, and Leo stands for loss of electrons is oxidation, gain of electrons is reduction. Okay, so we say that a compound or element that loses electrons is oxidized. And an example of this is magnesium, the solid. So it goes from a solid state to an aqueous form of magnesium, which is 2+ because it is in group 2 of the periodic table. So it loses 2 electrons. And this is an oxidation half reaction. And we then say that magnesium was the reducing agent. So the compound that is oxidized is always the reducing agent. And a compound or element that gains electrons is reduced. And an example of this is copper in its aqueous form, so copper 2+, plus 2 electrons will become copper in its solid state, and that's the reduction half reaction. And we then say that copper is the oxidizing agent. So when a compound or element is reduced, it is the oxidizing agent that is being reduced. So an example of when this is important to know could be they give you the reaction iron oxide plus aluminium in its solid state gives you aluminium oxide plus iron in its solid state. and they ask which one is being reduced. Now, just by looking at the reaction, we can see that iron has gone from being in a compound to just being an element. So that should tell you that that is the reduced one, but we're going to take the long way to find the answer. So first, we have to find the oxidation state of iron as it is in the compound iron oxide. And how you do that is you say it is the number of metals plus whatever it's bonded with, in this case oxygen, gives you the charge of the compound. The compound is neutral, so it's 0. So there are 2 irons plus 3 oxygens, and oxygen is a -2 charge, gives you a charge of 0. I take it to the other side, and I get 2 ions is +6, so 1 ion will have a charge of +3. Second step is to look at the iron oxidation state after the reaction. So over there it is just iron in its solid form, and that means that it has a charge of 0. It's neutral. So third step would be to just look at the change in oxidation state before and after the reaction. So iron goes from iron 3+ to iron in its elemental form of 0. So there were 3 electrons that were transferred. So it's iron 3+ plus 3 electrons gives you iron in its solid form. And so that tells us that iron is the reduced compound or element here. Thank you for watching this video, and if you want to see more videos, please check out my channel.